My screen visible now?
Yes, it is.
Like this one last week we created just the introduction to Python. What are variables? What are the print statements, the input statements? That's what we discussed last week. And today I'm moving on to the next phase of it, which is the types of operators are operations we have in Python. What are conditional statements and how they were being used? Then we have loop. What are loops and how are they being applied? Then that's the end of all we have to do with loop two. And based upon what we've learned earlier, what we discussed earlier, we have treated the first one, the operations that we have. We have arithmetic operation, we have comparison operation, we have logical operation, we have assignment operation, and we have membership operation, then identity operation. So we'll go through all of them to see how they are being applied in Python programming language. Though we have treated the arithmetic operation, we both know them, the addition, the subtraction, the multiplication. We have done them in one. All we have to do now is go through the comparison operators. What are they and how are they being used in Python programming languages? Because the presentation differs sometimes from one programming language to another. So moving on to the comparison, they are sometimes being referred to as relational operators. They show the relationship between two different variables. So the first one we have equal to, which is being like the symbol for the equal to is double equality sign. So it has to be true or false. Normally the result of this comparison operators is a Boolean value. It's either true or false. So if the condition is satisfied, the comparison satisfies, then the answer should be true. If it didn't satisfy, then the answer should be false. That's how they are. So equal to is taken if both of the operators or variables were equal. If both of them were equal, the values of their variables, if they are equal, then fine, it will return equal true. If they are not equal, it will return false. Not equal, it's been like represented like this exclamation mark plus equality sign. That means it shows that the one at the left hand side is not equal to the one at the right hand side. If it is true, then fine, it's true. If it is not, then false. So we have greater than. Greater than, we know the value for greater than is taken if a certain variable has higher value than the other. Still, less than is the inverse of greater than if a certain variable at this left hand side is greater than less than that of the one at the right hand side. Then we have greater than or equal to check the equality or greater than from the same value upward. If it is satisfied, then our answer is true. If it didn't, then our answer should be false. Then we have less than or these are the comparison operators that will be treated, six of them. So let's start with simple programming examples. Let's do something here. Let's create a new notebook for our workflow. Okay. So we are starting with comparison operators. Let's I say within the comparison operator, we started with not equal sign, equality sign. So what it does is that, for example, if I say 3 equals 4, what I'm doing here is I'm checking if 3 is the same thing as 4. So when I run this, definitely I will be having false as my answer here. And one thing about this is that when you are using these operators, you don't need to say print statement for it to for your answer to be printed. Just call the comparison operators, then your answer should be available. Unless if you want to make it a little bit into a readable format, so then you apply string formatting to it. Then just like looking at this example, let's say I have A16, B16, then So by equating A is equal to B, that means I'm checking if A and B are the same values. So if you look at this, I am having false here. So see the same thing. Let's say I have a certain value. Let's say A equals 20 and C equals, let's use this 2020. Yeah. Then A equals. If I say use a single equality sign, I'm not here. I'm assigning just like variable assignment. I'm assigning A like the value of B should be the value of A. That's the difference. But using, okay, let's look at this. If I print this, let's say I say, okay, I didn't have B. Let's say A equals C, for example, and I say C is 21. So by using the single equality sign, I'm assigning the value of C to A. But if I say double equality sign, that's comparison. It is comparing the values, not the variable. As I have told you last week, A is a variable. It's just like holder, pointer, a variable that is pointing to location where 20 is being stored. C is like a variable pointing to location where 21 is stored. So if I say A equals B, then I'm trying to check the value of A. Is this the same thing as the value of B? Then if I run this, I will be having first the same thing here, the last one. So if I say 2020 again, I'll be having true because A and 20 are the same thing, are the same number. But if I say, okay, let's take for example, I say this one is a string, this one, C is a string. So here, despite they have the same values, but the data type differs. A is 20, B is 20, C is 20. But here we have C as a string in a quotation mark. So if I say play this, I'll be having false. They are both 20. The only difference is that A is a numeric integer value and C is a string value. So that's how they are. A comparison. You are checking the exact values, not the variable. So we'll be seeing much of them when we are dealing with when we went in the conditional statement and the loops. We'll be seeing much of this comparison operator. So that's how equality sign works. Then let me comment this.
Okay, one. So in this case, since A is 20 and B is 20, that means A is equal to C, right?
No, it's not. Yeah, A is equals to C. No, it's not. Look at the answer false here.
But they are both 20s. A is 20 and B is 20. C is 20.
Yeah, they are both 20s, but look at this. The C is in a quotation.
Oh, that's a strange. Okay.
Okay, that's let me zoom it a bit for you. Are you looking at it?
Yeah.
So the C is in a quotation and A is just normal integer number.
Okay.
They are both 20, but the data type differs. So that's the major difference between the two. Then what's the next thing? Not equals to this. Our next operator is not equals to. So do not equal to, as we have said, is being represented using exclamation mark and equality sign. That's how it's being represented. So it's checked, it's just like inverse of equal to. The equal to is taken if they are the same. The not equals to is taken if they are not the same. That's just it. So let's take the same example that we have done before. A and C. Here, if I come and say A not equals C. Now, if I play this now, I should be having true here. Look at it. Because when I define A is 20 integer, C is 20 string. So therefore, I should be having something like this. And if, let's say I define B somewhere here, and let's say 20 let's say, let's give it a name, let's say 10. And I come here and say, okay, B not equals or C, whatever it is. So now if I play this thing also, I should be having true. The reason I'm just saying one single output is that it's just print the last comparison. That's how it is. But if I want them both to be printed, I have to put them inside the print function that we have explained last week. So if I want this to be printed, I should come here and say print this inside bracket. Okay. Print this. So by doing this, I should be integer. So if I do this, I should be having, I think, both of them. So if you want both of them to be printed, you have to include it here. So by default, the last line, if it is a comparison, it will be printed automatically. If I want it, I have to should be putting the print statement also. It will work. But so this is not equal to exclamation mark then equality sign. Then the next comparison operator we are having is greater than. So for the greater than, this is the symbol of it, an arrow pointing to the right hand side. So greater than is just like checking if the value at the left hand side, let's say if I say B greater than A, for example. Okay, let me just say C. So if the value here is greater than this, it will return true. If it is else, it will return false. So if I play this, should be not supported between instances, integer and string. Okay, C is a string value. So the reason for the error is, if you can remember, we define C as an integer. So comparison operator here, the greater than will not work between integer values. Look at the differences. We use it in equality sign, not equal sign, it works between integer and string. But greater than, since we are taking the higher value, we cannot compare integer and string. String has different precedence than integers. So that's why it didn't work. But between two numbers, we can find greater than. Between two, let's say for example, let's say I have, let's say D equals string A, for example. Then I have E equals string, let's say D. Let's try checking, yeah, if they will work. Yeah, let's say then let's check it if D is greater than E. Let's try checking between two integers as strings. It is false. Why? Because alphabetical numbers were arranged serially. A is 1, B is 2, C is like this up to the last value Z, which is 25. Is it 25 or 26? So if you check the value of A here is 1, D is around 4. So that means if I'm taking D equals greater than 1 is not greater than 4. So they use position to number the integer value. So I think is it ASCII? I think they use ASCII values if I can remember clearly, not that positional values. But sure, that's how it should be. We'll talk about it later on in details. That's even if we take these values, the ASCII D is still greater than A. And if we apply the same scenario that A is 1, B is 2, C is 3, D is 4, it still is the same thing. So for the greater than, we are checking if the one here is greater than the one by the right hand side. Then we have less than, which is almost the same thing opposite, just to check if let's say CD A is less than B that we have defined earlier. I think it should be false here. Is it true? Yeah, false. A is 20 and B is 10. So that's why we are having false here. So you see the same thing. We are checking if the one by the left hand side is less than the one by the right hand side. So that's how this less than works. Also, we have less than or equals, or let me say greater than or equals, which is something like greater than equals. So we attach them together, no space in between them. By putting space, it means something entirely. So it's just the same terminology is greater than, but now we are checking equality first. We check if are they equal, if they are equal, fine. Anything from the equality sign upward. Yeah, let's say if I say A is greater than or equals to, let's say, B. So what we are checking here is that we start with take the value of A is 20. Then we compare is 20 greater than B. Definitely 20, B is 10, 20 is greater than, so just return the two. And if, let's say, for example, it's not greater than, then we check the second condition. That's how it works. It starts with the first condition, then the second condition. There are two conditions combined here, greater than and equality sign. So instead of writing the equality sign double, that's why we just write it as a single. But there are two conditions combined. It first check the greater than. Is A greater than B? If it is greater than B, so there is no need for us to check the second one. It's just like if statement, we will come into the conditional statement also. So if the greater than satisfies, just return true. No need to check the second condition. But if this doesn't satisfy, then it goes and check the second condition again. So let's try running it. Definitely we'll be having something like true here. Yeah, true, because A is 20 and B is 10. But what if, let's try and check what I've just explained. What if I find B as 20 again? So what happens is that when I say by the single, if I take the single value and say A, let's try them, greater than B. Let me comment this. I'm coming. So if I say A greater than B, here I should be having something like false. Because A is 20 and I've defined 20 to be, I B to be 20 also. If I run it, I should be having false because they are the same values. A is 20, B is 20. I'm checking greater than here, just a single condition. But if I come here and say, okay, let me take the two conditions at a time. I'm checking the greater than and I'm checking the, what's it called? The equality sign. Yeah. So what you do is that if you change the first condition that we have just practiced here, A is greater than B, A is not greater than B definitely. Then it will go and check the second condition. Is A equal to B? So here A is 20, B is 20. So when we run this, we will having to. So that's how it works. It check the first one. If the first one satisfies, go is the determine one and the answer there. If it is not satisfied, then you check the second condition. So we'll see more of it in Mokazo conditional statement. So probably some stuff might be a little bit easier at that stage. Then we have less than or equals. So the same explanations. It check the less than first, then uh, after checking the less than, then it goes and let me define C as let's say something around 30. Then we say C less than um, let's say A, because A and B are the same now. So we are having false here because C is 30, A is 20. But if you match them together, still you will be having the same thing. Okay, should be something like this here. Still here we'll be having the same thing, false. Because if we check the second condition, the first condition less than, C is not less than A. And you check the equality condition, which C is not still equals to A. So after we run, we will still be having false here. So that's how like the conditional statement, okay, the comparison operators work. I think we finished all of them. Less than, greater than, yeah. So that's how they work. We'll be explaining them as we move into the conditional statement, if statement. We'll see how they work entirely. Then we have logical operators here. And the logical operators, they were three in numbers normally, the basic ones, the AND operator, the OR operator, and the NOT operator. So we have the exclusive OR and others, but these are the major three that we'll be treating. So AND, just like common logical operators, the first one we'll be treating is AND. And this AND is being written as AND, just one small AND. Yeah. No, there is a symbol for it also. So the AND is written as AND, A-N-D. What it does is that, let's say I'm having two values, two conditions, for example. So it checks if both of them, just like we have finished explaining this equalities and greater than. So what AND does is that it checks the first one and check the second one. If both of them they were satisfied, then I'll be having a positive answer, true. And if one of them is true and one of them is false, I will be having false. So let's try to explain this using a truth table. Uh, so the simplest way to explain this is using truth table, but let's continue this before we can fit. So let's say we have our A equals 22. Let's say B equals 20, as it is C equals, let's say, 30. And D equals, let's say, 22 also. Let's say I have these four variables and I want to like take some certain condition here. So in AND, I say it works on two conditions. If the first one is true, then the second one must be true also. I want this to open to fit. It's loading here. Okay. So let's say I say okay, A misali equals D, then AND in small letters because Python is case sensitive. Then I say B um, equals, let's say for example C. I'm citing an example here. So what happens is here is that this part is a single condition for and this part is a single condition. So what I've explained is that if for AND to be true, this part must be true and this part must be true also. Both of the two parts between the left and the right hand side of AND must be true. The first thing is it will check is A equals to D. If A is equals to D, then there we should be here we have to confirm. Then it goes to the other side and check if B equals to C. If this one is true also, so definitely our answer here is true. So what happened is that let's take this example. Say one is equal to okay. What happens is let's say I'm having true here, I'm having false here. Let's use confusion matrix stuff. So let's take this simple diagram, though it might be complicated, but let's explain it using this simple confusion matrix step. So we are using this for 2 by 2. Just ignore the rest. So for AND to work, we have to have true and true. Then by combining these two, a true and true, so that's where you'll be having true. Any other section, true and false, it will give you false F. And false and true, it will give you false also. Then false and false will give you false. So that's how AND operation works. If it both of them were true, so definitely our answer should be true. And if just one side, let's say if I play this one also, A equals to D is taking is a comparison here. A equals to, so A is 22, D is 22. So therefore this place is true. Here B is 20 and C is 30. This one is not true. If we play this cell, we will be having false. Because though the first part is true, the second part is not true. That's why we are having this. But if I say, okay, A is, for example, then I say less than or equals. B is less than or equals to C. If I check the value of B is 20, C is 30, B is less than C. So if we play this, we'll be having something like true here. That's how AND works. So it checks both sides. If both of them were true, so definitely our answer must be true. If one of them is not true, then our answer is not true. That's how AND operation works. Then we move on to the OR operation, I think. Yeah. The same thing in small letters, OR operation. So it's almost a bit similar to AND, but the major difference between them is that in OR operation, even if one of them is true, so both of the operations are true. For example, let's use the same expression. Yeah, AD, then O in small letters, B, let me start with the one we have deleted, equals C. If it is O here, just like the one we've drawn here, if it is O operation, if it is O, true and true here will give us true. Okay, sorry. True and true here will be having true here in O operation. True and false will be having true or false, sorry, will be having true. False and true will be having true. And false and false will be having false. So that's how O works. If either part of them is true, so definitely our answer is true. That's just it. Once you confirm the first part is true, just take it as the whole expression is true, as long as they were being combined with O. So if we check this, A equals D. A is and D are the same thing, 22, 22. O. So once this is true, if it is O here, you don't even bother taking the rest of the part, the rest of the expression. Just take your first, the thing you have experienced, your true as your final answer. But if the first one fails to be false, then it moves to check the second one. If the second one is true, so our answer is true also. But if the second one is not true, then the entire answer should be false. That means if both this one is false and this one is false, based upon what you have just drawn here. If a single part is true, so definitely duka part, all of the rest of the parts are true. But if both of them are false, then our answer is false in case of all statement. So um, let's run this thing and see. Because the first part is true, so definitely we'll be having true. So what if we change this as if not equals to, if you could remember. So now we change this expression to not equals. If we change it, what it does is that it takes the first one, A is not equals to D based on the expression here, but we know that A and D are the same thing, 22 ticker. This one is 22, this one is 22. So by checking if they are not equal, since they are equal, we'll be having false here. Then it's take the second part, B equals C. B and C are not the same thing, which is the same thing, false. So we have false here, we have false here. So definitely our answer should be false. But if, like, based upon what we are, let's say we edit this, for example, B less than or equals to C. So if we edit it around, we will be having to here. The reason is that since this one is false, it comes on to this part. B is less than C. B is 20, C is 30. So B is less than C. We'll be having true as part. So since the second part is true, the whole answer becomes true. So that's the major difference. In AND statement, the answer must be true if both of the both of the conditions you have at the both sides are true. And in OR statement, even if one part is true, the all of them is true. We might be having complex operations where we have more than two conditions. Just like this one is two conditions. I might be having some expression where I have another O here. So both of them, let's say I say A like it is greater than let's say C. Oh, yeah, let's leave it at this, less than. So we might be having complex expressions like this. This one should also return to because the middle one is true. In O, one part, if one of the expression is true, the whole of the expression becomes true. Just like a real life scenario, you might even say, like, okay, you want to go and buy something at a certain shop, or let me just say supermarket. Then probably your brother, okay, gave you, like, okay, if you are going there, please buy me Coke or what do you call the other one? Or let's say Fearless. So each one of them, either Coke or Fearless, you bought for him, it's still the same, it satisfies the condition you were given. Just like okay, we are coming to that one funny example. Yeah. So it's just the same thing in real life scenario. You have two options, this one or this one. So whichever one you have satisfy whatever you are looking for. That's all. But for and, both the two conditions must be satisfied for you to apply it. We'll be seeing much more of them as we move on. Then the last one we have not, negation operation. They both have their symbols. We'll discuss them as we move further. So the not operation is, we call it negation. I think it's not. Let's go and okay, yeah, not. We call it negation. What it does is it negates the true, like the condition that we have. Let's say I say not. Let me write here. That's how we write true. So what it does is that it's negation. When we say negating, inverse, it inverts whatever you put it after it. So here we have true, but not true. The inverse of true is what? Is false. So we'll be having false here. So if you put it at an expression, what it does is after the expression is being expressed, it answer, then it will invert the whole answer into another thing entirely. Let's take this simple example that we have explained. A is not equals D. So when we bring this, A and D are the same thing. Our answer should be something around false here. Yeah, false. Because A and D are the same thing. But when we negate this entire statement and say not, I think they should be in bracket. We should be expecting true here now. Because the initial answer of this expression is false. And this negation, not what it does is negate the answer for this expression. We are having true initially here and the opposite, just like opposite of whatever your answer is at that expression. That's how not works. So these are the logical operators. I think they are logical operators that we have. Any question before do I'm a little bit fast? Any question?
Good to go.
Right then, India. So um, these are logical operators. Don't worry, they are a little bit something like this, but we'll be using them much if we move into the conditional statement, this conditional statement and logical operators. So the next thing after is we have assignment operators. These assignment operators, like we've treated them in the first week. I don't know why. So, though we just treated them anyhow, we don't even know what they are. So the first one is assignment, just like we have been doing here. Uh, just like assigning operators here, equality here. You are assigning 22 to A. So whenever I say A, I'm referring to 22. You are assigning 20 to B. Whenever I say B, I'm referring to 20. So it's just like assignment. You are putting a name, a variable, you are attaching a variable with a value. Instead of calling 20, 20, 20, 20, it will be a little bit hectic. So whenever I say A, I'm referring, it's just assign values to a variable. Then we have add and addition plus subtraction, subtract. So like we explained them in week one. So we'll be using them as we move forward. Then we have membership. For the membership operations, we have two, in and not in. What they do in general is that they check the existence of a certain value within a given variable. Or let me say within a given data type. Then here it says it works in string, list, tuple, set, or dictionary, any one of them. Though we work only with string so far, the list and tuple should be next week probably or upper week. So what it does is that just like I've said, if it is in, so it check if the given value, or let me say variable or value, whatever it was given there, if it exists within the context of that same variable sequence of values. Not in it checks if it doesn't exist. It's just like inverse of each other. The in is checking the existence, and not it is checking if or non-existence. So if that value I'm looking for exists within that sequence, it will return true. If it didn't, then it will return something like false for me. So that's how they work. let's say should we write this? Okay, let's try writing them. Membership of results. So we see the first one we have E in small letter. So let's say let me define the values I'm having. Let's say x equals let's do this. Don't worry about whatever it is. List square bracket. We'll explain them 3, 5, 6. Let's say 7, 8, 1. Let's say I'm having this. Then have names equals okay. So the same thing. I have my name. Where's my one? Let's see. Do this. Uh, Egbe, your name. Egbe, how far?
Yeah, okay, well, this one with square bracket, is this a list, a tuple, or what?
This is a list. I said we'll be treating them in details
Okay,
next week. I'm just citing a example
okay,
here. There,
okay.
it's one of the data type that we have.
Square bracket.
We have list, we have tuple, we have set, we have dictionary.
Yes.
So list started with a square bracket also. It's enclosed within a square bracket. This is a list. We have a tuple, which is normal bracket that we have been using, normal open and closing bracket like this. This is a list. Then we have dictionary and set that have this curly braces. So that's one of the major differences between the four of them. A list is a square bracket. Whenever you see a square bracket, then the values inside it. So definitely it's a list. When you see a normal bracket that we know, so that one is a tuple. When you see square curly braces like this, so it's either a dictionary or a set. They have their differences between dictionary and a set. When we move on to that, we will explain it in details. How they differ. So now I just want to cite an example based upon this. So here is let's say we're having this list, Mr. X and Mr. and names. So so what we'll do is that let's try to check if a certain number exists. Let's say I want to check, let's say we have a list of let's say this serial number of a student, and you want to check if certain student is available, let's say attendance that we have taken during one of your lectures probably, and you want to check maybe someone complained to you, maybe they were there and you know that you want to confirm if they were there during that class or not. So now you can use this in statement to check their existence. What you do is you say, okay, what's the number? Ask the student for his number. Let's say the number is session number is 3. Then you say in X. That's just what it takes. 3 in X because the X contains something like whatever in number integers. So we are checking these 3 within this. Does it exist? You want to check if that certain student is available that day. Or let me say his name is within the attendance of that day. So you just press play. If it is there, so 3 is there, so definitely it will return true for you. So that means that student is available. So what if I say 4 here? So though we are looking at it by mere looking, this is just simple numbers. I'm just citing example because you might have hundred, bulky, thousands, millions of data that we will be dealing with. So you cannot go through them one after the other. So just use 4 in X. It will navigate through X and check is 4 in X. Then when you play this, by mere looking, we know that 4 is not. So definitely false. So definitely that student is not within during that lectures for probably. And if let's say for example you want to check for names, not the session numbers or whatever it is. You can check for names also. That is, I have the two, the string and integer. You can check anyone. Let's say you want to check certain value. Let's say we have someone like in names. Remember, you have to consider the data type of whatever you are dealing with. You want to check a string value, so the enclose is in a string. If you want to check integer, just like in this form, it's just integer. Integer doesn't have any string, so just leave it. Now I want to check either whether a certain string exists within the range of this list. So that's why I enclose it in this. So I started with a single double quote and I use this in a single quote. They are both the same thing. Anyone is okay. So when I press this, I should be having false because out of all the lists I'm having here, none of them is Adamu again. And if I put, let's say, I use this, so definitely I should be having true here because this person exists. So what if I mistakenly say A, for example? Let's try and see this. It will return false. Despite say we have so many A's within this, but we don't have A as a single entity. Because in this scenario, the whole of this A is a single entity. Our is a single entity. And the whole of this is a single entity. So I cannot just say I'm searching for I entirely generally. So there is a way to do that. We'll just come, we'll deal with them. These are slicing indexing. So we'll deal with how you can access a certain value within this. But generally here, this hour is a single entity, it is Igme Hazara is a single entity, all of them. And the what else? Yeah. So that's the in operation that we have. And I told you, if let's say now I'm just printing the last one. If I've written anything under this, this one will not be printed. If you want it to be printed, you have to include it inside the print statement. Print this, then so by doing this, so by doing this, you can whenever you run it, this one should be printed. So the same thing here. If you feel like you can just put it inside the print statement. So whenever I run this, they will be printed both of them. Let's see. So that's how they are. So let me just comment them to avoid confusion. Yeah. Oh, let's do this. Let me create another cell for a second. Not in. See the space between these two. Not in. They are not aligned as not in. There should be space between them. So choose something. It's just like inverse of before for the in you check the existence. For not in to check if a certain value does not exist or not. So So let's say 9 not in X. So now if I play this, I should be having true because in my X, look at it here, I don't have 9. So it's just like checking 9, is it in X or not? It's not in X, so I should be having true. I'm checking the non-existence, not existence. So the same thing in my names also, just they are just like inverse. I'm saying just like the name I've said before, let's say I have let's say A, not in names. So the same thing now I should be having true for this one because A is not in names and I'm checking the non-existence. So A is not in names. So the same thing I'm having true. So they are just inverse of each other. If you know how to use in, so the not in will not be difficult and there are certain conditions each one of them is applied to. So then so this is another example. Membership operation in dictionaries, just go through them. These are dictionary, this is how the dictionary is. We'll explain it in details, don't worry about it. Then we have identity operators also. Identity operators, they were two. Also, we have is and is not. So what it does is like it compare the memory location. For the equality sign, if you remember, we says equality sign. This one, it checks the value. If a certain value is the same thing as the second value, but in this identity, it checks the memory location. Are they pointing to the same memory? Like if you could remember the one of the, I think it says A equals to 5, if I could remember, and B equals to A. Then we have B plus equals 3. I think something like this. So I think one of the pictures that I've sent in the group is something like this. So what happens here is that when we say A, well, let me just one is it's not necessarily based on this expression. So when we say A is 5, we are pointing variable A to a memory location where 5 is located. Then when we say B is A, we are assigning B to A also, like we are setting B and A pointing to the same direction. So now let's say there might be a condition where you want to check, is it true that A and B are checking at the same, like are pointing to the same direction? So if you want to check that, na ga babu sai dai naka ɗiba. Awa. So A is B. So now I'm trying to check if A and B are pointing to the same memory location. So I have true. The reason is B is A is 5, B is A. They are pointing to the same memory location. And here, the reason, if you check at this, I think the answer you say is 8. Now, it's the same thing here as saying, sorry, here, though I will explain something that I shouldn't. Here, the same thing as saying B equals B plus 3. If you could remember during assignment operation that we have explained initially, where we have explained variable assignment, this B equals B plus 3 will override this B equals A, creating a new variable where B is located. So if I run this, before I commented this, I run it. If I run this, I should be having false here. The reason here is that B now is pointing to a separate location where this variable is being stored, B plus 3, let's say 5 plus 3. Before, B equals to A, when I commented this, look at the differences. It's a bit confusing sometimes, probably, I don't know. So B equals A in this place. That means B and A are pointing to where 5 is located. And then I come here and says, if I take this A is B, I should be having true here, the first one. But here, for example. So now, based on this, I think they should be able to explainable. Here, our answer, we should be having something to do here. Okay, I think it should be maybe for the purpose of reading after. Yeah, should be false. If I let this, if I run this again, this one will give me pre and true. Let me put print statement just to compare them. So these two statements I'm having, the first one is true, but the second one give me false. Here, because B and A are pointing to where 5 is, then I declare B again. So by doing this B equals B plus 3 override the previous one. That means B now is pointing to a different direction. So if I press play here, I should be having false at the second one. So that's how it works. You want to check if two variables you are working with point to the same direction, then you use it. If they are not pointing in the same direction, it will return false. If they are pointing in the same direction, you will be having true. So just like not in, it's just like the inverse of so then the is not is still the same thing. The inverse, just like you are checking if they are not the same or not. So so my battery is getting low.